Good day, everyone. We are the SE Group 4, and we are here to present to you our research proposal entitled Modeling and Simulation of Green Infrastructure in an Urban Catchment Area in Balanga City, Bataan using Stormwater Management Model. Cities and urban areas are now home for more than half of the world population, specifically 55% according to the United Nations, and it is expected to grow up to 68% by the year 2050. For the past decades, Philippines as a developing country faces continuous industrialization, commercialization, and modernization of living. According to the City of Balanga website, 6.28% of the land area of Balanga City is classified as urban areas and 45.89% is labeled as urban areas. That being said, the growing population in these urban areas directly affects the demands and land developments. Specifically, it results to the increase in impervious surfaces, which then leads to uncontrolled urban runoff, risking the area to pollution, flooding, and stream banks erosion. One of the well-known technologies that reduces and mitigates the impacts of runoff is the green infrastructure, which promotes sustainability and quality living. To address the impacts of urban stormwater runoff, this study focuses on three green infrastructure practices: bioretention areas, permeable pavements, and rain cisterns. These GI practices generally promote soil infiltration and decreases rapid runoff. Aside from evaluating the capability of these GIs to runoff quantity, their potential for pollutant removal will also be assessed. As for the indicator for runoff quality, this study focuses on the dissolved oxygen and biochemical oxygen demand. Dissolved oxygen concentration levels lower than 5 milligrams per liter cause stress to aquatic life. On the other hand, the biochemical oxygen demand indicates the amount of oxygen required. In addition to that, concentration levels of water bodies exceeding from 8 milligrams per liter is considered as severely polluted.
The study area is estimated to cover 68,171.23 square meter. And when you direct your attention in figure 7, you can see an old satellite image of the catchment area that shows the state of the location and land uses 4 years ago with an estimated permeable area of 52,700 square meter. Furthermore, as shown in figure 8, land developments have been recently built in the area, specifically the Bataan Terminal Complex and the SMCT Bataan, which is currently still on the process of construction. And because of this new land development, we have decided to choose the location as the study area. A study was conducted last 2018 regarding the water quality assessment in the province of Bataan, highlighting the quality of water of each towns. As summarized in the table 1, it has been found out that none of the towns passed the national standards in terms of BOD. Specifically, Balanga City has a recorded data of 203 milligrams per liter. And as for the DO, all towns fell below the criterion level except for the town of Morong and Orani. Balanga City, on the other hand, have recorded a data of 1.4 milligrams per liter. This elevated BOD concentration and low DO levels are indicative of polluted coastal water, and this combination is said to be dangerous to aquatic life. In addition to that, figure 9 presented the average monthly precipitation in Balanga City, with the months of July and August peaking up to more than 600 millimeters of recorded precipitation. And for the general objective, this research will evaluate impact of green infrastructure practices on runoff reduction, both quality and quantity, in an urban catchment area in Balanga City, Bataan, using stormwater management model. And for the specific objectives, we're going to examine the effects of GI practices on runoff volume reduction in simulation process. Next one is to determine the impact of GI practices on biochemical oxygen demand and dissolved oxygen concentration level. And lastly, to generate combined GI practices that will best perform on runoff quality and quantity enhancement. This study will be of great deal to add to the ongoing advancement of knowledge that aims to have a large and positive impact on addressing uncontrolled urban stormwater runoff, specifically here in Bataan. This study aims to generate results of combined scenarios for recommendation of implementing green infrastructure practices used in this research that addresses stormwater runoff quality and quantity. Also, this might be a good reference for future research here in Bataan to study and address other type of water pollutants using the same methods that we use. Also, and as for the future development, this study will be abounded with knowledge that can be maximized by the government agencies that is inclined in the subject. And necessary actions is a must regarding the problem stated for the community to benefit in the long run. Furthermore, this paper also aims to help on achieving Sustainable Development Goals 6, 9, 11, 13, and 14 with specific targets 6.3, improve quality, wastewater, wastewater treatment and safe reuse, target 6.6, protect and restore water-related ecosystems, target 9.4, upgrade infrastructure for sustainability, target 11.3, inclusive and sustainable urbanization, target 13.2, integrate climate change measure into national policies, strategies, and planning. Lastly, reduce marine pollution.
As for the review of related literature, we included the most related topic, which are stormwater runoff and harmful effects of stormwater runoff. It is known that impervious area increases due to land development, therefore causes stormwater runoff. The harmful effects of stormwater runoff are flooding, polluted water resources, and steam bank erosions, which are based on Hudson, Hazen Jim, and other authors. Next is the green infrastructure. It is mentioned by Norman's work that GI practices are a viable tool to meet the needs for ecological and environmental protection. The efficiency and assessment of three green infrastructures which will be used in this study are also mentioned and defined. So as you can see in the screen, this is the basis for the data of why three specific green infrastructures will be used in our study. As indicated in the summary of the table, rain cisterns and pavements show maximum percentage of implementation, followed by bioretention. Other green infrastructures were not implemented or cannot be implemented. The rest are on a micro scale which will not be applicable for this study. This is our conceptual framework, which is the basic overview or summary of this study. First is the stormwater runoff, which is the research problem. Next are the variables represented by boxes, which are rain cisterns, permeable pavement, and bioretention. These are the three GI that will be used in this study. The variables considered for the three GI are cost and effectivity, which are represented in colors as shown in the screen. Based on the table of data for green infrastructure shown earlier, permeable pavements is the most effective but most costly GI practice, followed by bioretention area, while cistern will be the least costly but least effective among the three. Other variables should also be considered, such as the runoff volume, geography of the location, and the catchment area. After considering all these variables, the simulation or implementation of the three green infrastructures will be done using the software needed for the study.
For theoretical framework, including the model of SWMM or Stormwater Management Model, and the key theories and parameters in terms of quality and quantity assessment of stormwater. SCSCN method, it is a method commonly used for estimating the quantity of runoff after a rainfall event in a particular area. It was first developed by Mocus et al. In 1949. Horton method calculates the infiltration capacity into the soil of the precipitation events. However, this method is divided into two parts. Therefore, another equation is to calculate for recovery during dry periods. It was first introduced by Horton in 1941. And cross-section method, it is denoted as flow of runoff equivalent to the cross-sectional area multiplied by the velocity of water. In terms of quality assessment, event mean concentration could be the suitable equation due to its relevance in reducing biochemical oxygen demand or BOD. And for model calibration and validation, coefficient of determination or R-squared, it is providing the information about the effectiveness of a certain model. Therefore, it is important to predict future outcomes or testing of hypotheses. And last, NSE, which normalizes model performance into an interpretable scale. It was first introduced by Nash et al. In 1970.
Here's our study's flowchart of methodology, starting from data collection, and then utilizing the QGIS software and using the stormwater management model for runoff simulation and hydrologic assessment of single and combined GI practices, up to the selection of optimal GI practices layout scenario.
Stormwater Management Models, or SWMM, utilized all over the world for stormwater runoff, combined and sanitary sewer, and other drainage system planning, analyzing, and design. SWMM was created to promote local, state, and national stormwater management goals of reducing runoff through infiltration and retention and reducing discharge that pollute water bodies. SCSCM method predicts runoff using an equation for a rainfall runoff curve that varies according to a single parameter called the curve number, or CN. A watershed antecedent potential water retention is described by dimension CN parameters. A Horton method, it describes how infiltration capacity decreases, and it is based on creating runoff when rainfall intensity exceeds the infiltration capacity. Furthermore, during dry times, the modified Horton equation represents the recovery of infiltration capacity. Event mean method, or EMC, is a significant analytical measure that relates to a flow wave average concentration in the entire rainfall runoff process, defined as a total pollution load mass divided by the total runoff volume. For R-squared, statistical measure that represents the proportion of variation explained by an independent variable or variable in a regression model of dependent variables. NSE is used to calculate the difference between the residual and the variation of the data that has been measured.
Our study Gantt chart that shows the project timeline, summarizing the activities that will be performed to acquire the expected outcome of this study. First is gathering data activity that will be performed on the entire month of March, and on the entire month of April will be allocated to model calibration and validation, together with the scenario design. Next is the simulation or implementation that will take place from mid-April to mid-March, while the result of the assessment will be on the entire month of May, and the data interpretation will be from half the month of May up to the last week of June, along with the writing of report that will be on the month of June. And lastly, the submission and presentation of the thesis will be in July.
And lastly, these are the list of references that we use for this presentation and we also use in our manuscript. That will be all, and thank you for listening to our group presentation.